Two charts that I have on this screen are actually part of a larger chart, or two parts of a larger chart that are on page 489 in your book. I've left off the inverse trigonometric function ones. We'll deal with that at a later time. All right, so we've discussed the second one up on the left. So we've discussed this one already. That's just your basic power rule, and that formula was on our previous video. This we've actually already basically talked about as well. Uh, the derivative of any constant is 0. So we can take the integral of any value, and so of any constant value, it goes to x, and we have an additional c as well in front of that. So they're kind of basically the same thing. And again, note here, n doesn't equal -1. We actually have something to do with the -1. Well, for obvious reasons, we can't do that because if x is -1, -1 plus 1 is our 0, and that just removes the x entirely, and that doesn't work. So we're going to use the natural log for that because the derivative of ln of x is 1 over x, which is x to the -1. Which means if we have the integral of 1 over x, that equals ln of x, and there's absolute values around that x. And the reason for that is because x can't be negative. Can't be 0, in fact, either. Can't be 0 for obvious reasons here. It would be undefined. That'd be a problem. So it has to follow the rules for natural log. The domain of natural log is from 0 to infinity, not including 0. So when we take the integral of 1 over x, it's going to be the absolute value of the natural log of the absolute value of x, and then plus some c. The derivative of e to the x is just e to the x, so the integral of e to the x is going to be e to the x as well, and then plus any constant. So our trigonometric functions are over on the right. The derivative of sine is cosine, so the integral of cosine will be sine, and then plus some c. The derivative of cosine gives us negative sine, so the integral of sine is going to be negative cosine, because if we take the derivative of negative cosine, we get a negative times negative cosine. Tangent. Derivative of tangent is secant squared, so the integral of secant squared will be tangent, and so forth. There's a list of all 6 of the trigonometric functions. The derivatives on the left, the integrals, which is a reverse procedure, on the right. All right, so I pulled out some questions from page 497. And let's try to tackle a few of these. All right, so number 470. I guess I can leave it like that. Number 470, I'm going to rewrite this. One over x squared is really x to the -2. So if I want to find f of x, that's the integral of x to the -2 plus x dx. So this is just two different power rule values. So this is going to equal x to the -2 plus 1 all over -2 plus 1. And this is x to the 1 plus 1 all over 1 plus 1. And then plus c. So our f of x, when it's cleaned up, this is x to the -1, which is 1 over x. I've got a negative here, so that's -1 over x. This one here, this will be x squared over 2, which is 1/2 x squared, and we still have our c. So that's number 470. Let's scroll down a little bit and attempt 471. All right, so we have f of x equals e to the x minus 3x squared plus sine of x. So it's adding in a lot of different things. So we're looking for capital F of x. That's the integral of the whole thing. Well, it doesn't matter. And I'll just add e to the x here. The order doesn't matter. Okay, so we have three individual integrals. That will do. Again, the sum of the integrals is the integral of the sum. So this one, the first one's our normal power rule, which is going to be negative 3x to the 2 plus 1 over 2 plus 1. All right, so the derivative of cosine is negative sine, so the integral of sine will be negative cosine of x. And the integral of e to the x is just e to the x, because the derivative of e to the x is e to the x. And this is b plus e to the x, and then plus some c. This one I'll run a check on. So let's first get it done. So that's going to be negative 3 over 3, which is negative 1. So x cubed. And this is going to be minus cosine of x plus e to the x and plus c. So let's do a check. So f prime of x, we're just going to take the derivative of this whole the whole thing, which will be negative 3x squared with the power rule, negative sine plus e to the x plus 0, which is negative 3x squared plus cosine of x plus e to the x, which is what we have there, only not quite in that order. All right, so that works. Let's do, I don't need to do 472. That's very similar to this. Let's do 473. So x minus 1 and 4 sine of 2x. This is okay. So we're looking for the integral of the whole thing. Is that what it is? Yep. Okay. We still have three separate ones. If you want to, set it up like that. So that's going to equal integral of x is going to be x to the 1 plus 1 over 1 plus 1. The integral of minus 1 is just negative x. Or if you prefer, x to the 0 plus 1 over 1 plus 1. All right, so this guy here. This guy, the integral of sine of the x is negative cosine of x. However, we have a 2x here instead. And there's going to be a way that we're going to deal with this probably more efficiently in the future. But what gives us something with the sine of 2x? So let's just do this. So if I said y is equal to cosine of 2x, our derivative would be 2 cosine of 2x. Excuse me. That would be sine, not cosine. 2 sine of 2x, and that's minus. So y prime would be negative 2 sine of 2x due to the chain rule of the 2x. So we've got something that we can break this up into. So we can take 2 times, let's do this over here. So let's take 4 sine of 2x. That's equivalent to negative 2 times negative 2 sine of 2x, which we already know the integral of that. Okay? So the integral of 4 sine of 2x equals the integral of, I'll put the negative 2 out here, it doesn't matter, negative 2 sine of 2x. Which equals negative 2, and we already know that goes to just cosine of 2x. So that's what's going to go on over there. I guess I can leave that. All right, and one more cleanup, and this will be 1/2 x squared minus x minus 2 cosine of 2x. And we'll get into the substitution method at a later time, but that would have made this a little easier as well.